Welcome back, smart mathematicians. We're continuing with our lesson on the counting principle, and then we're going to concentrate on the rule 2 and the factorial notation. Right, we have to understand what factorial notation, or why is it important that we use the factorial notation. Right, let's take, for example, this product 5 times 4 times 3 times 2 times 1. Instead of writing the whole thing like 5 times 4 times 3 times 2 times 1, we can write it in what? We can write it using the factorial notation, which is just 5 factorial. It is written like this. This is how we write it. And then it's read as 5 factorial. Okay? Like, for example, 4 factorial is like 4 times 3 times 2 times 1, which is 4 times 3, 12, 12 times 2, 24, 24 times 1 is 24. Okay, and then 9 factorial also is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right, and then we can use the calculator. We can use our calculator to find what? 9 factorial. We can use calculator to find 4 factorial. We can use the calculator with factorial notation. Okay, let me show you how. This is how you use the calculator with the factorial notation. So let's say 4 factorial. What you do, enter 4, and then shift, then there is factorial notation here, the second function, then equals. See that? 24, right? Or you can say, let's check 9. We say 9, shift, then factorial. See that? And then we get our answer. Okay, this is how we use the calculator. We can generalize and say n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 up to times 3 times 2 times 1. Okay, and remember that, or take note of this, right? 0 factorial is equal to 1, not 0. 0 factorial is equal to 1. Okay, let's look at this example. Consider the word solvent. How many possible word arrangements can be made from the word solvent if the letters may not be repeated? If you check here, how many letters do we have? We have 7 letters, meaning that we have 7 spaces. So we have space for this first letter, second letter, third letter, fourth letter, fifth, sixth, seventh. You see that? So the first letter, we have 7 choices here. So it means we're going to have 7 here. Then second letter, we have 6 choices. Third letter, 5 choices, 4 choices, 3 choices, 2 choices, and then 1 choice there. You see that? So how many different ways, how many different word arrangements can we have? We'll have 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, like this. So instead of writing this whole thing, we can just say what? 7 factorial, like that. Okay, right. So we have what here? 7 choices, because this letter is made up of what? 7 letters, and then we have 7 positions. Okay, please take note of that. We're going to use that as we conclude about our rule number 2. Right, then example 2. 5 public speakers have to sit on 5 seats. So it's 5 public speakers sitting on 5 seats. 5 public speakers have to sit on 5 seats reserved for them at the front. In how many ways can they be seated on these chairs? So we have 5 chairs here. We're saying that 5 people may be chosen to sit on the first seat. And then 4 people may be chosen to sit on the second seat. And then we're left with 3. 3 people can be chosen to sit on the third seat. We're left with 2. 2 people can be chosen to sit on the fourth seat. And then 1 person there for the fifth seat. So how many different arrangements here? We can say 5 times 4 times 3 times 2 times 1, which is 5 factorial. And then 120 ways. You see that? Okay, right. If we check our examples that we just did, we see that example 1, 7 letters took 7 positions. So we said 7 factorial. 7 letters taking 7 positions, we said 7 factorial. And then example 2, 5 public speakers taking 5 seats, we said 5 factorial. So this is where the rule 2 comes from. So say that if n spaces have to be filled from n different choices, the number of possible arrangements is n factorial. Please take note of that. If n spaces have to be filled from n different choices, the number of possible arrangements is n factorial. Like here, if let me use example 2. If 5 seats have to be filled by 5 different public speakers, then the number of different arrangements is 5 factorial. Okay, that's rule 2. Right. Okay.